So next we are going to see TCP IP model or TCP IP protocol suite. Actually, this TCP IP model was developed prior to our OSI ISO model. Actually, our OSI ISO model is having 7 layers, but this TCP IP model is having only 4 layers. And this TCP IP protocol suite does not exactly match with the ISO OSI model. In ISO OSI model, we are having 7 layers, and in the case of TCP IP protocol suite, we are having only 4 layers. The 4 layers are host to network layer, internet layer, transport layer, and application layer. These are the 4 layers. So when comparing with the OSI ISO model, this host to network layer can be compared with the physical layer and data link layer, and this internet layer can be compared with the network layer, and in both the protocol and both the model, transport layer is same. But in this case of TCP IP, this application layer can be compared with the presentation, session, and application. These 3 layers combined, and in TCP IP, it is acting as a single unit called application layer. This transport layer is doing a part of work of this session layer. So how many layers this TCP IP protocol suite is having? It is having 4 layers, that is host to network layer, internet layer, transport layer, and application layer. This TCP IP is a hierarchical protocol. Now, first, these are the 7 layers of OSI ISO model, that is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Now we are coming to TCP IP protocol suite. So this data link layer and physical layer, that can be combined into one layer, and the name of that layer is host to network layer in TCP IP. Okay. Next one is network layer or internet layer, and next one transport layer, and next one application layer. Now this is a comparison of the OSI ISO model and the TCP IP model. This data link and physical layer, these 2 are combined into one layer in the TCP IP, that is nothing called host to network layer. And next one is the internet layer or network layer. Okay, next one is a transport layer, then application, presentation, and session. These 3 are combined into one layer called applications layer. Okay, now when you are coming to the host to network layer, in the host to network layer, no protocols is defined. No protocols is defined, and you can use any standard protocols that is used by the underlying network. And this host to network layer is a lower layer of this TCP IP model, okay, or TCP IP protocol suite. This is a lower layer, and here it is responsible for the transmission of the bit stream, okay, or physical medium, transmission of data to the physical medium. This host to network layer is responsible. Next one is the network layer or internet layer. In this internet layer, it is defining some protocol, that is IP, interneting protocol, internetworking protocol, and ICMP, internet control messaging protocol. Then next one, internet group messaging protocol, and RARP, reverse address resolution protocol, and the next one ARP, that is address resolution protocol. These are the protocols defined in the internet layer of TCP IP protocol suite. So Next layer is a transport layer. In the transport layer, what is the function of this transport layer is it will assures the error-free transfer of message from source to destination. And in the transport layer, the type of protocol they have mentioned is transmission control protocol, stream control transmission protocol, and user datagram protocol. These are the three protocols that is mentioned in the transport layer. When coming into the application layer, the protocols defined are symbol mail transfer protocol, file transfer protocol, then hypertext transfer protocol, domain name system, simple network management protocol, and telnet. These are the protocols which are explained or that are defined in the application layer. So the function of application layer is it will connect the user to the network. Okay. Now we are going to see the function of each layer of TCP IP protocol suite. So already I have explained at the physical layer. Here the physical layer and data link layer, that here we are calling it as host to network layer. In the host to network layer, we are not mentioning any specific protocol. All the protocol, that is all the standard protocols it is supporting. Next one is network layer. In the network layer, it is supporting ARP, RARP, ICMP, and IGMP. Next one is internetworking protocol. So internetworking protocol is a transmission mechanism used by the TCP/IP protocols. So it is an unreliable and connectionless protocol, a best effort delivery service. If it is possible, it will do the best. If not, if any congestion or anything will happen, it will discard the packets. Okay, the term best effort means it provides no error checking or error tracking. Now next one is address resolution protocol. So ARP is used to find the physical address of the node when its internet address is not known. What is the use of address resolution protocol? So it is used to find the physical address of a particular node when the internet address of a particular node is not known. The next one is reverse address resolution protocol. The reverse address resolution protocol allows a host to discover its internet address when it knows only its physical address. It knows its physical address. If you want to find the internet address, then you can use a reverse address resolution protocol. Next one is internet control message protocol. So internet control message protocol is a mechanism used by the host and gateways to send notification of datagram problems back to the sender. ICMP sends query and error reporting messages. Next one is internet group message protocol. This IGMP is used to facilitate the simultaneous transmission of message to a group of recipients. So if you want to send some message to a group of recipients, then you have to go for internet group message protocol. Now we are coming for the transport layer. In the transport layer, you are having two protocols. One is TCP, that is transmission control protocol. Another one is UDP, that is user datagram protocol. It is responsible for delivery of message from one process to another process. Next one is user datagram protocol. It is a process to process protocol that adds only port address, checksum error control, and length information to the data from the upper layer. Okay, this is a function of user datagram protocol. Next one is transmission control protocol. It provides full transport layer connection oriented service to application. Already we have studied what is meant by a connection oriented service and connectionless service. Connection oriented service means if you want to send any data, before that you need to put a dedicated route. They have to create a dedicated route, a dedicated line. Resources should be allocated in advance. Okay, that is connection oriented service. Next one is stream control transmission protocol. It provides support for newer applications such as voice over the internet. So if you want to send voice over the internet, then you have to use stream control transmission protocol. It is a transport layer protocol that combines the best features of UDP and TCP. So the stream control transmission protocol, it will combine the features of user datagram protocol and transmission control protocol. Next is the application layer. The application layer in TCP IP is equivalent to the combined session, presentation, and application layers in OSI ISI model. Okay, already I have explained in the application layer of this TCP IP protocol suite is equal to the combined layers of session, presentation, and application. Okay,